Welcome everyone. My name is Saksham Sharma. Today we are going to see the solution of the paper of NSEM of the subject NAD. My roll number is IT2K2152 and the video is under the guidance of Saligram sir. Thank you. Let's begin. Subject NAD. Let's begin. Question number 1. Find the roots of the polynomial x square minus x minus 1 through the fixed point iteration method. Also make a table for the various possible equations and show their nature, whether they are convergent or divergent in nature. First of all, let us consider the assumptions. Let fx is equal to x square minus x minus 1 and f of 1 is equal to negative and f of 2 be positive. Hence, root is between point x is equal to 1 and x is equal to x equal to 2. So we can take x not is equal to 1.5 as median value. Now let the function fx is equal to x square minus x minus 1, where the following equation gx that can be made through fx. So we have created the table here, and gx root x plus 1 and so on. Now for the selection of correct gx, we are going to take more gx should be less than 1. If we if multiple value of gf are less than 1, then choose the least one. For the selection of correct gx should be less than 1. If multiple value of gx less than 1, then choose at least 1. The table is as follows. Now, the gx is equal to should be taken for the fixed point iteration method. Now, we are solving. Now, x naught is equal to 1.5, x1, so and so, and till x7. As the error between x7 and x6 is 0.000101, hence root of x square minus x minus 1 is 1.61800. B. Write an algorithm for finding the root of fx x to the power x minus 1 using fixed point iteration method. To find the root of function fx x to the power 2 minus x minus 1 is equal to 0, we can use fixed point iteration method with an appropriate iterative equation. Here is an algorithm that outlines the process. Start with initial guess for the roots. Let's call it x naught. Set a convergence criterion such as maximum number of iterations or a desired level of precision tolerance. Initialize the iteration counter. Let's call it I to 0. Repeat the following steps until the convergence or reaching the maximum number of iterations. A. Increment the iteration counter. I is equal to I plus 1. B. Compute the next iterate using the fixed point iteration formula x of I gx I minus 1, where gx is a function that transforms x. C. Check for convergence. If x x minus I minus 1 is smaller than tolerance, then the solution has converged. Exit the loop. If the maximum number of iteration I is reached, the method did not converge. Exit the loop. If solution converts the output xi as the approximate root of fx to our 0 is equal to 0, otherwise output an error message indicating that the method did not converge. The choice of the function gx depends on the problem. In this case, we can rewrite the equation fx is equal to x power 2 minus x minus 1 is equal to 0 as x is equal to gx, and solve for gx to obtain the iterative equation 0, 1. Now moving on to question number 2. Find the solution of the system of equations using iterative method. The equations are as follows: 20a plus b minus 2c equal to 17. 3a plus 20b minus c is equal to minus 18. 2a minus 3b plus 20c is equal to 17. We find the value of a, b, c in the respective equation by taking variables from one side. A is equal to 17 minus b plus 2c upon 20. B is equal to minus 18 minus 3a plus c is equal to 20. C is equal to minus 17 minus 2a plus 3b upon 20. Now let a is equal to 0 B not equal to 0, C not equal to 0. A is equal to 17 minus 0 plus 0 upon 20 is equal to minus 18 minus 0 plus 0 upon 20. C is equal to 17 minus 0 plus 0 upon 20. Now A1 will be 0.85, B1 is equal to minus 0.9, C1 is equal to 0.85. A17. Now solving for the values, we would get A2 is equal to 0.98, B2 is equal to minus 0.985, C2 is equal to 0.63. Now solving again, we would get A3 is equal to 0.96225, B2 is equal to minus 1.00155, C3 is equal to 0.6042. Now again solving, A4 is equal to 0.961195, B4 is equal to 1 point minus 1.0141, C4 is equal to 0.6014. We will follow these steps till we get repeated approximate values. Now question number 4. List out 4 disadvantages of Gauss elimination and 3 advantages of iterative methods over the elimination methods. The iterative method is superior to the elimination method due first computational effort is approximately 2 to the power 2 n to power 2 arithmetic operations per iteration, and if the convergence uh, is achieved in less than n iteration, it is significantly superior compared to the elimination method. Another important advantage of the iterative method is small rounding error. The rounding error being the one committed in the last iteration, thus for ill-conditioned system, an iterative method is a good choice. Third, in a Gauss-Seidel method, we set xi equal to newly calculated value of the iterate stored in temp. The disadvantage of Gauss elimination are as follows. The computational effort is approximately 2 and 3 by 3 arithmetic operations in each elimination step. The amount of bookkeeping necessary is considerable. The rounding error may become quite large, particularly for ill-conditioned equations. Any special structure in the matrix of coefficient is difficult to preserve during elimination. The right algorithm for Lagrange inverse interpolation. So the algorithm is as follows. Step 1. Read number of inputs and read the value of x. Third, for I equal to 0 to I n minus 1, read xi, yi. Step 4. Set sum is equal to 0. For I is equal to 0 to I is equal to n minus 1, set product is equal to 1. For j is equal to 0 to j is equal to n minus 1, if I not equal to j, product is equal to product into y minus yi on yi minus yj. Sum is equal to sum plus xi into product. Sixth step, line class step is print sum. Now evaluate the equation using the 3-point Gauss quadrature formula for the given abscissa and weight. T1 is equal to 0.77459667, T2 is equal to 0, T3 is equal to minus T1, W1 is equal to minus 0.555556, W2 is equal to 0.8889, W3 is equal to W1. Let A is equal to 0, B equal to 1, x equal to b minus a upon 2 into t plus b plus a by 2. Putting the values of a and b, x is equal to 1 plus t by 2, dx is equal to dt by 2. Substituting the value of x and dx in the fx, ft is equal to 1 minus 1 to 1 2 divided by 4 plus 1 plus t whole square to dt. Now ft will be bracket 0.555556 f minus 0.7745 plus f 0.7745 plus 0.888 double 89 bracket f naught. Now for minus 1 to 1 to 4 divided by 4 plus 1 plus t whole square dt is equal to 0.555556 in bracket 0.4937. In this case, the value of C is very small and may be lost due to the limited precision of floating point arithmetic. This can lead to inaccurate results and numerical instability, especially if C is used in subsequent calculation. To avoid this problem, it is recommended to use an alternate formulation of the problem that avoids taking difference of two nearly equal numbers. This can involve algebraic manipulation or reordering of the calculations to reduce sensitivity of small changes in the input. If it is not possible to avoid taking the difference of two nearly equal numbers, it is recommended to take difference before performing other operations. This can help to reduce the impact of the loss of the precision and improve accuracy of the results. Overall, avoiding the difference of two nearly equal numbers and taking difference before performing other operations can help to improve the accuracy and numerical stability of the algorithm that involve floating point arithmetic. Third question. Adding or subtracting numbers is starting with the smallest numbers and work with numbers in ascending order. Explanation. Adding or subtracting numbers with the smallest numbers and working with numbers in ascending order can help to improve the accuracy and stability of the calculation. When adding or subtracting numbers with different magnitude, it is important to start with the smallest number to reduce the impact of the limited precision of floating point arithmetic. This is because small numbers have fewer digits and are less sensitive to rounding errors than large numbers. By working with numbers in ascending order, we can also reduce the accumulation of rounding errors and numerical instability. This is because rounding errors accumulate more rapidly when adding or subtracting large numbers, while small numbers are less sensitive to these errors. For example, consider the following calculation: A is equal to 1.23, B is equal to 0.004, C is equal to 45.67, D is equal to 0.0005. If we add these numbers in descending order, we get A plus C plus D, B plus D is equal to 46.9035. However, if we add them in ascending order, we get result is equal to B plus D plus A plus C is equal to 46.9035. In this case, adding the small number first reduces the impact of rounding errors and improve the accuracy of the result. Overall, adding or subtracting numbers, starting with the smallest numbers and working with numbers in ascending order, can help to improve the accuracy and numerical stability of the calculation, especially when dealing with floating point arithmetic. Fourth, use not for 23 plus 0.27976 plus 0.88889.4. Now again from minus 1 to 1, 2 divided by 4 plus 1 in bracket 1 plus t whole square dt is equal to 0.78527. Answer. Another next question. Write an algorithm for the Weedle rule for the points 6 points. First, read and h is equal to n minus start by 6 for I is equal to 0 to I tail to 6. We will follow a loop. Read y I. Fifth step, s is equal to zero point 0.3 h y naught plus 5 y1 plus y2 plus 6 y3 plus y4 plus 5 y5 plus y6. Last step, print s. Next question. Write the algorithm for hand cutter method. Fourth order expression. Step 1. Def f x comma y defining a function. Return expression. Second, read starting ending splits. Third, h is equal to ending minus starting upon splits. While starting is smaller than equal to ending, k1 is equal to h into fxy. K2 is equal to h into fx plus h divided by 2 y plus k1 divided by 2 k3 h into f x plus h divided by 2 plus comma y plus k2 divided by 2 k4 h h into f x plus h y plus k3 x is equal to x plus h starting is equal to starting plus h y is equal to k plus 1 plus 2k2 plus 2k3 plus k4 divided by 6 plus y0. Now we'll print x comma y. Apply predictor character method to solve dy by dx is equal to minus x into y comma y to 0 is equal to 1 in steps of point 1 up to y point 2 y to power p yn plus 2 yn plus 2hf xn plus 1 yn plus 1 ycn plus 1 yn plus h divided by 2 is equal to f xn comma yn plus fx xn plus 1 yn plus 2. By Young's method, k1 will be f x comma I xi comma yi. K2 will be fx xi plus h divided by 2 comma yi plus k1h divided by 2. K is equal to k plus 1 plus k2 divided by 2. Yi plus 1 is equal to yi plus kh. Hence y point 1 is equal to 0.9975. Y 0.02 is equal to y0 plus 2hf x 0.101 y 0.01 predicted. Y 0.02 would give 1 plus 2x0 into 1x minus 0.1 f0 0.9975 y zero point 0 is equal to 0.98005 y 0.2 is equal to y 0.1 plus h divided by 2 into f x 0.01 comma y 0.01 plus f x 0.02 y 0.02 predicted. Y 0.02 is equal to 0.9975 plus 0.12 point minus 1 x naught is 11775 minus 0.2 x 0.98005 y is equal to 0.982712 corrected. We can apply the corrector formula again for more accurate values by putting this corrected value as predicted value in the correction formula. C. Applied the least square principle to fit a parabola in the given data sets. Develop an algorithm for this best fit form parabola. To fit a parabola to a given set of data using the least squares principle, we can follow these steps. Step 1. Gather the data. Collect the data points x, I, yi from the given problem or dataset. Step 2. Define the model. We assume the equation of a parabola y is equal to ax power 2 plus bx plus c, where A, comma B, and C are the coefficients to be determined. Step 3. The system of equation. For each data point xi, comma yi, we have axi power 2 plus bxi plus c is equal to yi. Rearrange the equation to axi power 2 plus bxi is equal to yi minus c. Step 4. Apply the least squares principle. Square each equation and sum them up over all data points. Sigma axi power 2 plus bxi power 2 is equal to sigma yi minus c power 2. Expand the equation and express it in terms of the coefficients a, comma b and c. Sigma a to power 2 into x I power 4 plus 2ab into x I power 3 plus b power 2 plus 2ac into xi into 2 plus 2bc into xi plus c power 2 is equal to sigma yi power 2 minus 2y ic plus 2 power c power 2. Step 5. Solve the system of equations. Express the above equations as a system of linear equations in terms of the coefficients a, comma b, and c. Solve the system of equations using standard methods such as matrix operation or Gaussian elimination. Step 6. Calculate the best fit parabola. Once the coefficients a, comma b, and c are determined, the best fit parabola equation is obtained. Thank you for watching. This was the solution. My name is Saksham Sharma, and I am from MTech branch of IIT 2K21 from IIPS DAVB. Thank you.